Imagine standing at a grocery checkout, and because of the language you speak, your bill is automatically multiplied by 15. The person in front of you pays $1 for a bottle of water. You must pay $15 for the exact same bottle. This is not a hypothetical scenario. It is happening right now silently inside every major artificial intelligence model on Earth. Most people believe that when we type a prompt into an AI, the system reads our words, understands their meaning, and writes back. We assume it is just as fluent in Hindi, Japanese, or Swahili as it is in English. But this is the first great misconception of the algorithm age. AI does not read letters, words, or sentences. It reads numbers. Before an LLM can process a single syllable of your prompt, it must run the text through an invisible translator called a tokenizer. This tool chops human language into tiny mathematical fragments called tokens. To an AI, the word "the" is just the number 26. But how these fragments are sliced is where the system begins to break. Think of tokenization like an automated kitchen equipped with a single standardized cookie cutter. This cutter was designed in Silicon Valley, shaped specifically to stamp out English dough into neat uniform squares. When you feed it English text, it cuts clean whole words with almost zero waste. But non-English languages are not made of the same dough. They have different curves, symbols, and grammatical structures. When the cutter strikes a language like Hindi or Arabic, it cannot stamp clean shapes. Instead, it strikes repeatedly, chopping a single word into dozens of jagged, meaningless scraps. This algorithm is called Byte Pair Encoding, or BP. It is a greedy statistical method that scans massive pools of internet text and groups the most frequent letter combinations together. Because the internet is overwhelmingly English, the tokenizer learns that English combinations are the default. It leaves everything else as fragmented dust. This structural bias is not just an academic curiosity. It is an economic penalty. Because cloud AI companies charge customers by the token, the cost of running these models scales directly with how many fragments a tokenizer produces. In 2023, researchers exposed this disparity, revealing a massive invisible tax on the global south. The exact same paragraph containing the exact same meaning requires vastly more tokens in other languages. While a prompt in English might cost 50 tokens, the identical query in Telugu or Burmese can take up to 15 times more computational space. For a startup in Nairobi or Mumbai trying to build AI services, their operational costs are instantly multiplied. They are paying a premium tax simply because their native language does not fit the English-centric grid of modern silicon. Beyond the financial toll, there is a cognitive cost. When Byte Pair Encoding chops words into meaningless segments, it destroys the logical connections the AI needs to think. This is especially true for agglutinative languages like Turkish, Finnish, or Korean, and morphologically rich languages like Tamil. In these languages, words are constructed like complex puzzles. A root word is combined with prefixes and suffixes to indicate tense, gender, case, and emotion, all in a single unified word. But BP is blind to grammar. It sees a long Turkish word and blindly slices it down the middle, separating the root from its grammatical meaning. This destroys the structural logic of the language. It forces the AI to spend its processing power trying to stitch these mutilated pieces back together, resulting in models that are fundamentally slower and more prone to hallucinating when working outside of English. The AI research community has hit a hard wall. We cannot build a truly global intelligence on a foundation that mutilates human speech. In response, a quiet rebellion is taking place in research labs. In April 25, researchers introduced MorphTok, a system designed to teach AI linguistic structure before it cuts anything up. By using morphology-aware pre-tokenization, it respects the natural boundaries of Indian languages like Hindi and Marathi. More recently, in March 26, a groundbreaking paper introduced VerChol. This is a grammar-first tokenizer designed specifically for agglutinative languages. Instead of relying on blind statistical frequencies, VerChol parses words based on actual grammatical rules, keeping roots and suffixes intact. These preprints prove that we do not need bigger models to make AI fairer. We need to change how AI sees the world in the first place. If the solution is clear, why haven't the giants of Silicon Valley adopted it? The answer lies in the brutal math of deep learning. A tokenizer is not an application you can update with a patch. It is the absolute bedrock of the entire neural network. If you change how a model tokenizes text, every single weight and parameter inside that multi-billion-dollar brain becomes instantly obsolete. To deploy a fairer tokenizer, companies like OpenAI or Google would have to throw away their existing models and retrain them from scratch, costing hundreds of millions of dollars in electricity and compute. For tech giants, the financial incentive is to keep the current English-centric infrastructure and let the rest of the world pay the token tax. It is a classic market failure where structural bias is subsidized by the users who are most harmed by it. This leaves us at a critical crossroads. As AI becomes the operating system for global education, healthcare, and governance, we risk a new form of digital colonization. If we continue on this path, entire cultures will be forced to simplify their written languages or abandon them entirely in professional settings just to communicate efficiently with machines. The fight for grammar-first tokenizers is not just about saving fractions of a cent on API calls. It is about cognitive sovereignty. It is about ensuring that the future of human knowledge is not filtered through an artificial lens that only speaks English, leaving the rich, diverse languages of the world lost in translation.